I'm working on a new project that requires displaying 00 to 99 and decided to use 7-segment displays. When I looked online for methods of multiplexing these two displays, I found what I would call the traditional method, which multiplexes the digits one at a time, a complete digit and then the other complete digit. But I didn't care much for what was required in the way of parts to make that work. So I found another way, which is multiplexing segment by segment. So let's look at the traditional method that you find online anytime you look up multiplexing 7-segment displays. You can see that the individual segments are driven in common, and the common cathode, in this case, cathode pins, are turned on individually with transistors. The transistors are needed because you might have to sync as many as 8 LEDs worth of current to display, for example, the number 8 and the decimal point, and that's probably pushing your luck a bit on microprocessor port pins as to how much current they can actually sync. So the transistor is there to make that easy. All the port has to do is to turn on the transistor, which it does very simply. The individual resistors in the segment lines are needed to make sure that each segment is lit up equally brightly, no matter how many segments are turned on. But the problem with this, it's like Mozart, too many notes. There's just too many parts here, and I wanted to find a way that would eliminate the need for these. So let's look at how this works. In the old method, we've got, in the case of D0 here on the right, we've got 5 segments lit up and the common cathode for that digit lit up. And then looking at the next one, we've got 4 segments lit up and the common cathode. So I wanted to find something that works better than that, and came up with this circuit, and that's used to multiplex segment by segment. You can see there's only one resistor required for each common cathode and no resistors required on the segment lines. So this starts out multiplexing segment A, turns on segment A and only segment A, and then it's the common cathode lines that determine on which digits segment A lights up. So in this case, we've got one digit has this segment lit up and the other one doesn't. Now we move to the second segment and both of them have it lit up. So both of the common cathodes are on. And as you go through each segment line one at a time, now notice that the common cathode processor port pins never have to sync more than 1 segment's worth of current. Each digit has its own common cathode and the resistor, and it only syncs 1 segment's current at a time. However, the segment driver lines will have to source current depending on the number of digits there are. So in this case, it's sourcing current for both of the G segments. How many you can do may depend on how efficient your displays are, but that would be the limiting factor in this method, if there is one. So now let's take a look at this multiplexing method in slow motion. And here we've got the 2 digits in the center. And on the right, I've rigged up indicators in red showing when the segment lines are turned on. And down at the bottom in green, you have indicators for the common cathode lines. And the thing to notice here is that the segment drivers just simply cycle one at a time over and over again, no matter what is being displayed, whether any of the segments are being lit up or not. It's the common cathodes that decide what lights up. So let me speed this up now, and about every 7 seconds or so, the refresh rate will double. And at the end, we'll see how things look. The final refresh rate that you see here is 70 hertz, 71 hertz. This is an interrupt every 2 milliseconds. But of course, every segment is on only 1/7 of the time. So the refresh rate about 71 hertz, and that's plenty fast enough to avoid any flickering or shimmering or anything. In fact, you can probably get away with something close to half that rate and still look all right. Now, at some point you may decide that this is still too many notes, that there are too many processor port pins dedicated to multiplexing these displays. Or you may want to do a large number of digits, and the current requirements on the segments is too high. So the question comes up as to whether there's an intermediate decoder chip we could use for the segment lines that would take that burden off the processor and let us get away with using far fewer pins. And it turns out that, at least for the common cathode displays, there is. And it's the 74HC4017, the modern version of the old CD4017. It says it's a decade counter divider with 10 decoded outputs, but that's just silly. What it really is a segment driver decoder for multiplexing 7-segment displays by segment. It's a simple chip. It's 16 pins. This is jelly bean stuff. It's cheap. You have a clock, and you of course have a clock enable, which you just tie low. The master reset is active high, and you have your individual outputs. And what happens is that every time you clock the chip, the next output goes high. Only that one goes high. So it looks like this. Every clock chip, one output is high. It just cycles over and over again, which is exactly what we want it to do. Remember the slow motion. That's exactly what the segment lines do. So here's the schematic of what you end up with if you use this chip. In this case, it shows using the decimal point. So it uses Q0 through Q7, eight segments in total. The output after Q7 is simply tied directly to the master reset. So when Q8 goes high, it resets the chip, and now Q0 is high. So it cycles through as many as you need and then starts over again, depending on what the reset's connected to. The remaining problem here is the initial state of this chip, and it doesn't power up in any predictable way. You could dedicate a processor pin to the master reset, but I'd hate to waste it on that. Instead, if you just put a high value resistor between Q0 and the clock pin, then you can clock the chip and then switch your I/O port pin to input mode, which is floating then. And then the output state of Q0 you can simply read on the port. and you keep clocking and reading until you finally get to Q0 high, and you've got it initialized where you want it, and then you simply put a port back in output, and you're done. The thing to notice here is that I'm driving 2 7-segment displays, and with the aid of this 4017, I'm using exactly 3 processor pins. And the number of pins you need is the number of digits you're using plus 1. And I think that's pretty efficient for processor pins. Now I need to say a word about the displays I'm using because it matters. My system is a 3.3 volt processor, and the total current required to display 88 is 4 milliamps. These are Vishay TDSR 1360 common cathode displays, and you notice the K after that. In the datasheet, you will see that the TDSR 1360, the plain one, you could get lucky like I did and end up with a Group K intensity classification, which is really bright for your milliamp. But you're not guaranteed to get that. All they guarantee you is that only one group classification will be in a tube, but tubes may vary. So you're kind of taking a luck of the draw there. But looking again up at the top, Vishay also offers a 1360 IK, and that limits the contents to the top 2 intensity groups. I think that's the safest way to order them. I got my plain 1360s from Arrow. They do not stock the IK. DigiKey stocks the IK, doesn't stock the regular. Mouser, I believe, stocks both of them. Notice that this applies only to the 1360 common cathode. They do not provide any such IK for the common anode 1350. So here's my circuit with the Texas Instruments processor. It has exactly 2 resistors, and I can't really complain about the current draw, and I think even Mozart would be happy with this one. So next time you try 7-segment displays, you might give this a shot. I should add that I've written Arduino sketches that are demonstration code for both the regular bi-segment and the 4017 bi-segment setups, just to show how you might code them if you use this method. And those are on my GitHub repository, and I'll post that here somewhere, or you can just search GitHub for multiplexing by segment. Thanks.